I'm just going to assume that it's good and just go ahead and get started. My name's Rick Torzynski, and this session is Machine Learning in Drupal with TensorFlow.js. And my development history, I've been a Drupal developer for 12 years working on government agency websites, healthcare Drupal websites, machine learning applications, and software engineer. I'm currently a senior Drupal developer at ECS, which is a company that does government contracts, doing US government agency websites. And before that, I was a contractor with Tech Systems as a Drupal developer at Florida Blue, working on the Medicare website for Florida Blue, Drupal 8 custom module design, and also adding content. And I also worked at NLP Logic, which is a local company here in Jacksonville, Florida, that does machine learning applications. And specifically, they did OCR application that would take manually made insurance forms and use OCR and then use machine learning to increase the accuracy of the OCR and put those actually into a database. And I was a Python programmer for that. What's our agenda for this talk? I'm going to give a short introduction to machine learning. I don't want to spend as much time as I can actually in the demo, so I'll go over that quickly. What is deep learning, which is a subfield of machine learning? What is TensorFlow.js? And then talk about Drupal and machine learning, how Drupal is utilizing machine learning applications right now and how that can be improved. Now talk about the component module understanding, because that's a key component of the module that I'm developing, TensorFlow.js. And then I'll do a demo of a couple of machine learning applications within Drupal, and then talk about some of the things that I'm looking forward to doing in the future, and then have time for questions. This is a picture of Andrew Ning. He's probably one of the top people in machine learning in the world. And when I was taking a course, his course at Coursera on machine learning, he had this quote where he said, "Just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of any industry that I don't think AI will transform in the next several years." And he's a Stanford professor, and he's also co-founder of Coursera. And he's actually saying that machine learning is revolutionary. It's going to change. It's already changed the way things are done with facial recognition, self-driving cars, so many applications, and it's kind of ubiquitous within businesses now. And a lot of businesses are actually going towards an AI first approach and making a central part, including the company I'm working for, ECS. They're really have a major stake in developing AI and machine learning applications. Some of the companies that are currently have been leveraging machine learning applications and devices. Probably the top one here is NVIDIA. And actually NVIDIA, I think, is the one we really have to thank, and also all the gamers, because the GPU was developed so people could play games. A GPU is a graphic processing unit, which is really good at making quick calculations, mathematical calculations. And that's a central part of machine learning. So without GPUs, I don't think we'd have such a big interest in machine learning. They also design edge devices, such as their Jetson Nano, which actually has a GPU on board. It's kind of a Raspberry Pi on steroids. and their new initiative is Omniverse, and they're trying to connect virtual worlds, different people all over the world, so they can actually interact through these virtual worlds. Facebook is another company with facial recognition, friend recommenders, and also they develop PyTorch, which is another machine learning framework that's used quite a bit in machine learning. Of course, Tesla we have, so they're doing self-driving cars, because machine learning is behind really why self-driving cars are being developed. They're actually getting quite good at this, still have their problems, they're not perfect. And also Elon Musk recently said that Tesla is going to be actually designing a robot, so that should be interesting. LinkedIn with job search, networking, again, recommendations and everything. They're a big player in it. Other companies using machine learning, Amazon's, banks for credit card fraud. Airports are now using facial recognition, so you don't even have to show your ID. You can just step up to a camera and it will recognize you with a pretty high level of accuracy. So what is machine learning? Well, machine learning focuses on applications that learn from experience and improve their decision-making or predictive accuracy over time. I have predictive accuracy, or predictive, that's the key word in this sentence, is because you're actually, when we say that machine learning models are learning, what we're saying that they're actually getting better at predicting some outcome. And that's a key thing, as we shall see. There's different types of machine learning. There's what's called supervised learning, where for a set of data, the outcome is already known. This might be like linear regression in statistics, where you have your X values and your Y values, and you're trying to figure out the line through the data that minimizes the amount of error. So you actually, if you have a set of input data and then you have the result, so you know what the result is, so you use that to train. So when you then present another input value that hasn't been used in training, that it can actually predict that value. And this is also true of like classification type models for like image recognition for what type of objects. Say you got pictures of cats, dogs, cows, and horses. So you have a set of data, pictures of these different animals, and you throw them into your training data, and it actually comes up with a model. So then you can show it another picture that it hasn't seen, and it can tell you what it is. So that's what we mean by supervised training. We already have the label for the data set. There's also unsupervised learning, where the outcome is unknown, but you're interested in how the data clusters together into groups. Examples of this would be in statistics, you have principal component analysis. So it looks how the data kind of clusters together, how there's similar ideas or objects. And so you can actually kind of classify them into different groups or clusters. And recommendations are also, recommenders are also like this, because there's not an actual outcome value that you can predict, but you want to see what items are kind of similar and vary in the same way, so that you can use these as they'll be good recommenders because they should be in the same group. The other big difference between machine learning and traditional programming, you start out with, you have your data and you have certain rules or operations. So this example here is you have some data where you have the price and earnings, and you want to calculate the price earnings ratio. So you take the price and divide it by the earning, and you get your answer. So that's this traditional programming. You have your data coming in, your rules, and you get an answer. While in machine learning, I said supervised learning, you have the outcome. So you have the answer and you have the data. And what you're trying to do is figure out these rules. So how do we know like that picture is of a dog and not a cat? So we want to figure out these rules, and that's what machine learning does. And so this is the key to machine learning is in this difference in the paradigms. So in machine learning, you already have the answers. You have your input data, and you're trying to figure out the rules. Because you want to be able to predict the values given that you have some input data. You want to be able to figure out what the answer is going to be. What is deep learning? Deep learning, you'll also hear that term. This is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural networks. Here's an illustration. And these neural networks have been around in psychology. I remember 30 years ago studying about neural networks, but we didn't have any way to actually calculate these values and methodology, but now we do. So this has really come back. But these are actually structured on how the neurons in the brain work. And this was how people were figuring out, how do we humans learn information? So that's what this is modeled on. And so what you have, these red nodes or cells are the input layer. So you're going to have the information coming into this model. And this could be anything quantifiable. It could be images, because you can quantify an image by looking at the pixel value of each, the color value of each pixel. And you can put that in there. And there's ways that this middle section is called the hidden layers. And this is where actually the machine learning takes on. There's something called activation functions, which modify the weights that are then pushed into the next cell. So if we have more layers, so the activation function determines what value is going to go to each of the next cells and goes through this. And this is where the model actually learns. What they call this, you're looking for features. So if you're looking at images, these one feature might be edges. So a feature that might be pulled out is that it can detect like vertical edges. So that would be one of the features. And then the blue layer is the output layer. And that's where actually the classification or the result is done. So if we had pictures, again, for different type of animals, each of these outputs would be one of those classifications, one of those categories. And the one with the highest probability of, because this is using what's called a softmax activation, because that's what you use for categories for classification. This value, so you would look at which one of these has the highest value. So that would determine, well, this one would be a dog, so it must be a dog if this one is the highest one. And this is what's used in image, because I'm using images. There's something called convolutional neural networks. It's the most common form for doing image classification. And so you have your image, and again, it's broken down into pixels. You're going to have 3 layers because you have red, green, and blue, the RGB colors. The information goes in here. And this convolution layer is just a way of kind of summarizing a piece of the information into a smaller piece. So it kind of summarizes the information and it's passed in. And then there's something called pooling where it actually picks the greatest value. I don't want to get too much into this, but this is all the hidden layers. And then out here, it's flattened into a single, like a vector for each one. And there's what's called a fully connected layer. And then there's actually the softmax, which again, these are all the classifications. So each one of these is going to have a value. And so the way that the model learns is it does this one time, gets the values, and then it checks to see how good it predicted, because you know the outcome. So you look at the amount of error in your prediction. And so all these layers are going to generate weights. And so the weights are adjusted, and it goes back to the beginning and does it all again. And it keeps going back, adjusting, trying to reduce that error, because that's what it's trying to do, is to minimize the amount of error in the prediction. And you're doing this on your test data. And what you do after that is you've been training on these images, you know the results. Well, what if you have an image that the model hasn't seen? How well does it do on that one? And that's called a validity set. And you can check to see how well your model generalizes to other images that it hasn't seen in the training image. Just wanted, and I said unsupervised learning. An example would be a recommendation engine. So any sort of like a product recommendation at Amazon. You have your user and you have all these inputs, ratings of products you've rated in the past, maybe your buying behaviors, what you've bought in the past, queries, what you've searched for. Behaviors could also be, well, what have you been looking for? And it all goes in here. And then it combines this information with databases on with other users' preferences. So what is someone similar to you? What are they looking at? And what do people who bought the items that you've bought, what do they buy? And so all this information goes in through kind of combining them all together into a single value, and then it will output a recommendation of products for you. And that's what you're presented. And so that's just an example of unsupervised learning. So what is TensorFlow? And this is a big thing. This is really a game changer, TensorFlow.js. Because in machine learning up till now, the language most used for machine learning was Python, which is a high-level language, very similar to PHP. Has, like Composer, has a package management manager. There's pip, which also does the same thing. So all these dependencies can be managed by pip. And you can also, with Python, what's real nice is you can use virtual environments. So you don't have to you just install these dependencies within a virtual environment, so it doesn't affect your whole system and just makes things a lot easier. And usually the method of programming, real common method, is to use what are called notebooks, Jupyter notebooks, and also Google has Colab, which is it's like an interactive in-browser editor, and also you can run code, and you can also annotate the code with not only comments, but you can actually put images in there, and actually it's very powerful. It's a great way to learn a language and teach language. You can also use integrated development environments, Visual Studio Code, PyCharm. It's one of my favorites. I also use Visual Studio Code quite a bit. There are also other languages used. R is a big one, Java, C++, Julia, and now JavaScript. And again, this is kind of game changing because it really opens it up, because it's still helpful to learn, know Python, but JavaScript you can do a lot, because a lot of times you don't need to do necessarily the training. I'll talk about that later, but it just makes it a lot more accessible to more developers. Just a brief history of TensorFlow. In 2011, Google Brain developed TensorFlow. They released it to the public in 2015, and they decided, well, we got this great thing. We can use it in Python, Java, C++. Well, can we use it in JavaScript? So they thought, why can't we use the client side to do this? So they started working on DeepLearn.js. And in 2018, DeepLearn was merged with TensorFlow to become TensorFlow.js. And I think they're up to version 2.9, something like that. But it's been around for a few years. 2019, TensorFlow Lite is released, and this is TensorFlow, a lightweight version that can be put on mobile devices or edge devices like Raspberry Pis or Jetson Nanos or Google's Coral. So you can actually run these with very low overhead. So what about Drupal and machine learning? Drupal is supposed to be on the cutting edge, but I haven't really seen that within so much. There's not a lot of use of machine learning within Drupal. There was three machine learning modules, machine learning libraries, Drupal Compute, Recommender API. These were for Drupal 7. They've never been developed for Drupal 8. In fact, a couple of years ago, I went on as co-maintainer that, and I was going to port them to Drupal 8. But when I found TensorFlow.js and some other ways, other JavaScript programs to do machine learning like ML5, I didn't think this was the best option, because what these modules did would allow you to use Python or Java code underneath and kind of interface with the results through the Drupal queue. So it didn't seem very easy way. It wasn't very easy to do. So when TensorFlow.js came out, I put my efforts more to doing that. And then what really happened, another big change, is I think it was January of this year, the component module came out. And the component module allows you to run JavaScript within a block and create little components that you can drop into your block layout, just like you would like a plugin. So it just made it really easy to use JavaScript, and TensorFlow was the perfect match. I started experimenting and it worked great. The other thing the component module does, it allows you to do JavaScript configuration actually in your block configuration. So you can add values in there, which is real powerful. And Drupal's set up to work with JavaScript. So, I mean, that's why I didn't really work on the development of the other modules, because just JavaScript is just a good, better match for Drupal and PHP. So TensorFlow.js, this is a fully developed JavaScript library. It's been released on Node as well, so you can use it there. Uses WebGL to access GPU for processing, so they really speeded it up. and they added a lot of enhancements to actually speed it up. So it's been really optimized for JavaScript and within the client. They've also, TensorFlow, they've set up publicly available data sets. So if you need to do training, there's a collection of data sets that you can grab. Like some of the most well-known ones are like the MNIST for handwritten letters and also numbers, digits. I actually competed recently, and Andrew Ning had a competition and is actually doing Roman numerals. So that was real interesting. TensorFlow Hub is a setup, and that's a collection of pre-trained models. So these are models like ResNet. So there's some models that have like 1,000 objects in there that it will recognize. And you can just grab these, and you don't have to do the training, because that's where the big intensive processing is done, is actually within during the training. So you can actually get a pre-trained model, use that, and they can also be converted. These can be converted in Python to TensorFlow.js models, and these are actually JavaScript JSON models that you can incorporate. So it just makes it a lot easier to do. And also this allows you to do what's called transfer learning. So you have those 1,000 objects. Well, what if you want to add some new objects that is not in that library? Well, what you can do is you can use what the model has already learned for those other objects and just apply them to your new objects. And you just add a couple of layers. And so you can just transfer learning is just so powerful. So you can just add more. So just increase the number of objects actually within that library. So understanding the component module, this is a custom module. It has a dependency on the component contributed module. And so you can actually design your own different components. And what's great about this is, so I have a TensorFlow one set up under this directory. And then this is your configuration file. And you can set up different components. And these components will have their own configuration and also a template where you can put HTML and just kind of space for the component to work in. And then you have your JavaScript file for your functionality. And you can also, within these configuration files, you can also pull in other libraries. So in creating a custom component module, you create TensorFlow. So for this custom module, you have an overall one, which is just really pulling in the dependency on the component contributed module. And then you define your own configuration for your YAML file, JavaScript file, and then your index. Hang on. Speakers. Can everyone still hear me? Yes, okay. Sorry, my headphones beeped at me, so I wasn't sure. I'm speaking kind of fast because I want to get to the demo. And after you create your custom module, then you just have to add your component block to a page through the block layout, configure it there. So now it's demo time. Like I said, I wanted to get to this as quick as I could. I've set up some demos here. So I've actually created all the files within here. Just a quick look at them. So this is this first linear regression. You have your configuration file, just the name of it, where your JavaScript file is. This is dependency. So here I'm actually pulling in TensorFlow from a CDN and then defining where my JavaScript file is. Index, usually this is a lot less complex, but I set up kind of a special one for this demonstration. So everything's, I could have put it in the page itself, but I just did it this way so it would be part of the code. And then your JavaScript file, and I'll go over this a little bit. And here I used, I enclosed this within a Drupal behavior just to make sure that it got pulled in at the right time and taken care of. And so here I'm going to talk about this is kind of the hello world of machine learning is linear regression. Because again, the same idea in statistics, you're trying to figure out the line that goes through all these points that minimizes the amount of error. And if you put a line through here, the distance from the line to the, so this particular item probably would have a little bit of error. And this distance between the line and the point is actually how much error. You might be familiar with this from statistics. Y predicted or Y hat equals mx plus b, where m is the slope of the line, which is rise over run, and b is the y-intercept. So we're going to do this through TensorFlow. And so this is the JavaScript file. I just put it in here. Again, a Drupal behavior. So I'm just looking for the button click. So actually, when I press this button, this will actually do the training. And so this is the JavaScript for TensorFlow. And I'm just defining some data. It's called TensorFlow because it works with what are called tensors, which are just, you can think of them as n-dimensional matrices. And so this one, they're just one-dimensional because they're just points on the line. So we have our x's and our y's, and our y's are actually our answers. So so usually in TensorFlow, you have your data definition and pre-processing, and then you're going to define your model. We're using sequential model, and we're just going to have one layer. Well, this is the input layer, and basically it's just going to output the answer based on that. And again, like in statistics, this loss is the loss function, and this is what we're trying to minimize. And there's different ways that you can calculate loss. So we're going to use the mean squared error because that's what you do when you calculate it in statistics. I've done a lot of statistics as well. So that's just basically y predicted minus the mean of y. And then you square that value, because if there's a negative value, you want a positive. The optimizer this is just the way it defines the learning rate and the momentum. And this SGD stands for stochastic gradient descent. And so basically, we're going to look for reducing that because you want to find kind of the low point. I'm not going to worry about that. I just want to get through, show how the model works. So now here, I'm printing out model summary, and this will all go to console. So here's my call to the training method. And then I'm just chaining this together. And actually, so after I do the training, I'm going to predict the Y value when X is 10. So we're going to see the result there. And we're actually going to compare that to what the calculation would come out with. This is an asynchronous function because you want to wait for it to go through the training. The epochs, this is the number of loops that it's going to make. So it's going to do this 50 times to try and minimize the error. And this callback at the end of each epoch, it's going to output some information. It's going to show the loss function to the console log at the end of each epoch. So you can kind of see the training going on. And so I'm going to show my console. And training, it goes fast. So here it's just showing the model. We just have one layer. And then you can see this is showing the loss for each epoch. We're doing 50 epochs. So you should see the number go down. Okay, so the number goes down. So now here Y is when X is 10, it's predicting that's going to be 17.80. And this is going to show you the actual, the MX plus B. So we have the M, we have the B. And so now let's compare that to what the statistical calculation showed. So if you do the calculations, here's the line that minimizes the error. Estimated 10, 18.92. Oh, 17.80. That's not too good. So it wasn't very accurate, but the reason is I only did 50 epochs. So that's not nearly enough. So you can see that the number is going down. And what you'll usually see is this number will go down and reach a minimum and just kind of slowly change from there. That's what they mean by gradient descent, that this kind of goes out into kind of a declining curve and approaches zero, because that's what you're looking for. So 50 epochs, you can see in JavaScript. So maybe we should go change this. But remember I said we can set configuration with the component module. So what I've done is going to do the same problem, but in TensorFlow, in this function, we're actually going to use the configuration value. Well, how do we get that? We didn't set it. Well, we can do that. Sorry, actually. See, here's where you place the block. So this component, so we're looking at TensorFlow regression 2. So I can look in here and now there's a configuration that I can put in here, and 250. So I'm going to increase it. So that's a great thing about the component modules. You can actually put your JavaScript configurations into this block so you can change them. You don't have to actually go in and make a code change. So that's what I'm going to do. Save that block. Like to clear the cache. So you can see here, the state is defined, defining the model the same way. And here, see, here's where you get the number of epochs from the configuration. You get those, you're actually pulling out, and the component module tells you how to do this. So you're just looking at the block classes and IDs to pull them out of there. Now, the other thing that TensorFlow has is they have TensorFlow.js Viz, which is a visualization module. So I've added that into this. So instead of outputting it to the console, I'm going to actually show it graphically. And I'll show you what I mean by that. So now it's actually showing you real time. It goes through, and this is actually doing the training. Here's our loss function, and you can see how it's slowly declining, which is what you want to see. So 140. You know, we just have a few values here, so you can imagine the amount of calculations, and that's why the GPU is such a great thing to have. And that reached the end there. And I can also, I think I just, well, I did output it to the console as well, just the model, and actually, so now it's predicting 18.77. And if we look at our calculation, 18.92. So a little bit better. So maybe a few more epochs, because maybe it didn't reach the bottom there. And so that's, so just a lot of useful things. And it looks like I'm running out of time. I also had a recommendation engine, which was pretty cool. I'll just show you that real quick. So recommendation engine, that's kind of the code. And what this is a book database. I think it's from Goodreads, and it has about 5 million ratings. And so this is a model I actually ran in Colab. So this is Colab. So I actually run this and see each of these are little code blocks that you can run. So I just imported that module into the recommendation engine. And so the only thing it's doing is I can give it a user. And it's going to show me 5 books that person recommends. And you can imagine you could hook this into Drupal Commerce and everything. And I think I'm out of time, so I'm going to stop sharing my screen. And yes, Alexi, I will put it up on a GitHub. I'll put that out and do that. Are there any questions? Yeah, Hitchhiker's Guide to the Universe. Yes, all these calculations are running within the browser. Python is just, really the libraries don't exist in PHP. There's just so much easier. And that's why this is such a great way to do it, is using JavaScript, because you can still do the work. Well, Python. It's just, Python has just been really optimized for that. Okay, with the Colab, at the end of this, actually do the training. So this was, like I said, a training on 53,000 users, 10,000 books, and with 5,976,000 ratings. And so this training for 25 epochs took about 4 hours within Colab and the loss function. But what you can do at the end is you can save the model and then convert it actually into TensorFlow. And so this produces a JavaScript file that you can, a JSON file that you can just import. And that's what I did within the book recommender. And I didn't share my screen on that, so you didn't see that. Sorry about that. So let me go back to the Colab. This is the Colab, like I was talking about. I wasn't sharing my screen. So here's where I did 25 epochs, and like I said, this took about 4 hours on Colab. And the thing about this is Colab, it's through Google, but you can also I'm actually running this using a TPU, which is Google's their tensor processing unit, which is like a GPU. It's a little bit quicker. It's their solution. Yeah, I mean, to explain the original for image recognition, Alexa, it's just really using those convolutional layers. It just, you do enough of those layers and you have enough of the cells, and it can really figure out mathematically what the object is. I mean, they're getting, 98% recognition. And Ignacy, the training is not so much, I just did the training to show how the machine learning could be done within there. But the big thing is actually doing the inference, where the recommendation engine, I didn't do the training on that within the client side, because you only do that really one time to get your model. And of course, you want to continually improve your model, so you'll continually add new training to it. That's part of, there's a new discipline, ML Ops, which is looking at the life cycle of machine learning application, from building the model, data collection, all the way through deployment, and then continually improving it, looking for errors and everything. Is there server-side integration? Yes, like I said, TensorFlow is available through NPM, so you can actually do it on the server side. You can also incorporate it into like React apps for mobile devices and everything. Okay, let me just, hopefully I've addressed those questions. Just real quick, looking to the future, I'm continuing to work on the TensorFlow.js module right now. I have a dev version up. I haven't been able to work on it. I started a new job in April at ECS, and I also moved into a new house, so I've been kind of busy. My next big thing is I'm currently working on AI chatbot. So using and NLP, natural language processing, to actually create a bot that can respond to like frequently asked questions types things. That's another good thing to work on would be a recommendation engine for Drupal Commerce and job recommender. Just finishing out, I better finish this out. Just want to say thank you for all that attended. I know that it's kind of quick. I hope it was helpful. And just if you have further questions, just contact me. And I'd also like to thank Matt from Esteemed. He's been helping me do these talks. Hopefully, I think I'm getting better and better, feeling a little bit more comfortable, but I appreciate all of his help. And also my colleagues at Esteemed. And Esteemed, if you Drupal developers don't know, it's a great community for Drupal developers. They also can help you find a job. They're kind of a recruiter company. And most of all, I thank God. And so if you have any feedback, I mean, you can feel free to go to the schedule and put your feedback.